know that all of those were domain problems? What do the answers look like? And who does domain measure? X's. Good. So can you guys kind of be like me for a second? I know what these ones were asking. Well, A, I know they're matching because they're letters, right? But B, I also know what they were asking you to do because of the Y's. What was it asking for you to do or to see because of the Y's? Good. Range. Okay? So we have domains and we have ranges. Now, in your worksheet, you guys just had your worksheets out a second ago. For anyone that got stuck on 5 through 20, what I bet you missed was that there was a hint that you were always supposed to use to find domain. You were supposed to take something from each and every one of those problems. Okay, it's written right there. You were supposed to take something from each and every one of those problems and set it, greater than or equal to 0. And a special name for it was the radicand. Who's the radicand? When you guys were doing homework in 10-1A, what's underneath the square root? So for number 5, you were supposed to take the x and set it greater than or equal to 0. For number 6, you were supposed to take the 4x. Set him greater than or equal to 0, whatever is underneath the radical. But what happens, guys, when you solve for x in number 6? Divide by 4. When you divide by 4, what do you get? Got it. Let's go to one that's a little bit harder, though. What if you were to go down to number 10? If anybody missed that one. Who's the radicand in number 10? X plus 7. Do you guys have work shown? Because you should. None of this should be done in your head. Do you have work shown? You should have taken that radicand just like the worksheet told you, just like the examples we did in class. You should have boxed it and thought he's greater than or equal to 0. But how do we solve for x? Yeah, so then what's our final answer for that one? X is greater than or equal to -7, just like the worksheet shows. Adrian, where's your homework? Because you said you got stuck on that. That means you started it. That means it should be open, especially if I'm telling you exactly how most of 5 through 20 was done. It was drawing a box, setting it greater than or equal to 0, and solving. So, Adrian, if you took the box, x plus 7, and set it greater than or equal to 0, would you have known what to do? Yeah, you totally would have. -7. So the correct answer to number 10 should have been as easy as x greater than or equal to -7. All you needed was the worksheet, and all you needed was to read what I tell you to write down. That said, how do you do domain? Domain. How do you do domain? Domain. How do you do domain? Box greater than or equal to 0. So my 2 people that came to me and said, I was totally stuck on all of homework. It means you didn't look at your worksheet, and you didn't follow the pattern that I told you to use. Of course we could do whiteboard problems, and I really hope you come in. But I'm also really hoping that you start using what I give you in class every day. These worksheets are meant to help. How many of you guys were like, this homework wasn't too bad if I followed my worksheet? Oh. Only 2? Only 3? Really? Okay, so hold on. What do I need to do to reteach box greater than or equal to 0? Because if only 4 people in the entire class know what to do if you ask for domain, I don't really know how to make it easier, guys. Who's the radicand? The guy underneath the radical. What did I draw to try to help you guys identify him? A box. So in all of numbers 5 through 14, anytime you saw a radical, what were you supposed to think? A box. And what were you supposed to fill in the box? The expression. Yeah. And then solve for x. I know you guys know how to -7. I know you guys know how to divide 4. I don't know how to make it much easier. You see why I'm kind of scared? Okay. Were there any other ones that you guys missed? Number 6 through 14? Or numbers 5 through 14, I should say? Yeah, Kayla. Yeah, it got a little weirder down there, right? 14 specifically? Cool. Number 14, I'm not saying they're all easy. I'm just trying to see if you know the idea. Did you know what to do? All you have to do is follow your worksheet. So number 14, I'm going to go ahead and put a box of the part under the radical. Who is that? -x minus 2. I'm going to set that box greater than or equal to 0. Now guys, you have to use your algebra skills. Come on. What's the very first thing that we should do? Plus 2. You got it. The worksheet told you how to start, and then your algebra sense should tell you how to finish. Now we have negative x greater than or equal to positive 2, but am I done? Good. Divide by a negative 1. But hold on, everybody. What do we need to be careful of whenever we multiply or divide an inequality by a negative? Flip. And a positive 2 divided by a negative 1? Check it. Got it. Is that good, kid? So don't let the stuff in front confuse you. Still just take that radicand, the guy under the square root only, and set him greater than or equal to 0. Is that cool? And then just, watch out for those little multiply, divide, negative guys, because they flip it. Is there anything else 5 through 14? Nope. Anything else 5 through 14? Maybe in a second. Okay, so then that first homework, didn't it keep going past number 14? It kept going to 20. So then what happened in the next section? Oh, matching. Matching. Hopefully that one wasn't too bad. You guys can see over here, number 16 was C and number 18 was B. But it also says describe the range. So let's review range really quickly. Domain is easy if you remember. Take the radicand and set him greater than or equal to 0. It's a formula that you have to memorize. I'm sorry. It is what it is. But it comes from all that radical work that we talked about how if the radical exists, this box must be 0 or positives. It can never be negatives. We've talked about that a long time now. So it comes from a concept that you should understand, but for a lot of you, it's going to be a lot easier just to memorize that, and that's how your homework would have been possible. But 15, 16, 17, 18, you were supposed to match. You were supposed to match. And when you were trying to match it, maybe some of you guys used tables, maybe some of you guys used domains, maybe some of you guys used kind of just like guessing by looking at the graphs. But as I'm looking at these guys, based on all the work that we did in our tables, do you guys see that we would have used 0, 1, 4, 9 for this guy and for this guy? 16 and 17, why would we have used 0, 1, 4, 9 for both of those? What's true about the radicand? You can't see? It's supposed to be in your paper. I'm pointing to 16 and 17. You guys should be looking at 16 and 17 in your homework, yeah? But I can zoom in. How do I know that 16 and 17 would be really good ones for x to equal 0, 1, 2, 1, 4, 9, like in our tables?
Oh, the first one's just underneath?
Yeah, just x, right? Just x underneath. So then technically it's like, 0, 1, 4, 9. If I plugged in 0, this guy's at 0. So who's the only guy who's at 0, 0? C. So that goes with C because he's the only guy that's at 0, 0 if I started to fill in my table. This guy, if I started to fill in my table with, once again, 0, I would plug in 0. Square root of 0 is 0 minus 3. Is anybody at 0, negative 3? This guy is. Right? This guy, if I was to plug into my table, is at 0, 0. So I knew that he was the guy who went with the 0, 0 point. This guy has 0, negative 3. And then I could look at the other two guys, and I could have made tables out of them. But guys, why does this table start at 3 instead of 0? From yesterday and the day before, why would my table start at 3? Yeah, because I can plug in 3, and what's 3 minus 3?
0.
Yeah, and square root of 0 is?
0.
I like that guy, remember? And do you guys remember that the comparison language from last night, this shifted to the right 3? So who's shifting to the right 3? Oh, Steve. Both of these guys are. Do you see how both of them have 3, 0?
Yeah.
That guy does and that guy does? Uh-oh. Well, hold on. What would have gone next in this one? Shifting right 3, we have 0, then we have 1. 1 minus 3 is negative 2, right? Or plus 3? Nope, I did it the wrong way. I did minus when I should have done the opposite sign like I've been telling you guys. That should be 4, now it's hard to see. Shifting right 3, what's right 3 from 1, or adding 3 to 1? Wouldn't that be 4? Plugging in 4, what's 4 minus 3? What's square root of 1?
1.
Okay, which one has a point at 4, 1? Not that guy. That guy. See him?
Yeah.
So then I could have matched D with this guy, number 15, in process of elimination. If I had made my table with this guy, I would have seen him going, wait a minute, in your comparison language from last night, what happens if I have a negative on the inside? Everson, Andrew, stop. Andrew, move over 2 seats, please, and thank you. What happens when there's a negative on the inside? It's a flip over the... I'll wait. Do what you need to do. You guys have worksheets, and the worksheets tell you exactly what the answer is. I'll wait. What happens when there's a negative on the inside? Who can find the right worksheet in the right space to help us with the comparison language? Kayla's looking. Is anybody else going to beat her?
Graph flips over XY.
Yeah, which one? So if the negative's on the inside, is that over the X or over the Y? Good, 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 good. Do you guys see how this one flipped over?
Yeah.
A vertical one? So actually maybe you could have made that match, but we didn't learn the comparison language until yesterday, so maybe it would have been a little bit harder. If you were just trying to use the comparison language of shifting right 3, or down 3, or stretching up 3, or flipping over. Anyway, all of those comparison languages could have actually helped you make the matches without using any tables. And then finally, numbers 19 and 20, you guys were making graphs, and that's where you picked up last night. So let's go ahead and look at last night's homework, the one that's freshest on your mind. The one from the weekend, I understand, might be a little rusty. But reviewing domain, reviewing range, let's go look at last night's homework, which started on number 22. And he's down here. So number 22 and 24, you guys can check those graphs on the back of your paper. Remember, you only had 6 problems last night, and they were all graphs. So check your graph for 22. Did you guys get this guy to be shifted down 2? And did you use your tables correctly? Did you plug into your tables, hopefully, 0, 1, 4, and 9? Did you guys use your tables properly? I would have plugged in 0, 1, 4, and 9 for this one. For number 24, this guy shifted comparison language. If you tried to use what we saw yesterday, this guy shifted left 4, and so that would have been -4, -3, 0, and 5. That would have been a great table for you guys to make.
Like for 22, when like the X is just like when it's just X.
Always 0, 1, 4, 9. Yeah. And that comes back to that parent function that we talked about starting in 10.1a. That parent function, square roots, we love it when there's a 0, a 1, a 4, and a 9. And so, yeah, you're right. Whenever we have a radicand of just an X, we can totally just steal those same numbers. But when we start shifting, that's when we start adding or subtracting.
And can you explain why, like, can you do it again, like for 24?
So 24, you see how I see the +4 underneath? If you think about that comparison language, I don't think you had to actually write it for this section. I think you started writing the comparisons down here. But I was using that comparison language to help out as to how I made my table, because we're going to shift left 4, because remember, inside is backwards. So I see the plus, but it's actually going to be going the other way, left. And so check it. I'm going to take each and every one of my x's, and I'm going to go left 4. But in math, if you're going left on a number line, you're subtracting. So I'm going to take 0, and left 4 on a number line would be moving it to -4.
Okay. So whatever like the words are, like this one was shift left, then you do your graph like that?
Yeah. So I'm going to do, and how I got the rest of my numbers is I did 0 minus 4, 1 minus 4, 4 minus 4, and 9 minus 4. Does that make sense? But yeah, you're right. I'm using this guy as like my basis or my foundation. That's why we call him our parent function for radicals. Is that cool? And then once you have your X's, now you know to plug in and then find your Y's. Is that okay? So then that brings us perfectly into the next section, because the next section, guys, I gave you all odds, no evens, so you could look at the graphs in the back of the book. But for all of these, can I just double check with you real fast your comparison language? Actually, I don't remember what was next. 24, 20, 22, 24, 25. Oh, 25 was another graph. I'm sorry. But he was an odd. Let's keep going. Number 27, 29, and 33. 27, did you guys get him to be, if you were being really snazzy, a vertical shrink by 1/4? Are you looking at your number 27? You were supposed to do the comparison language. Did you eventually, for the comparison, yes, you have a graph. For the comparison, did you get a vertical shrink by 1/4? For 29, did you get a shift left 3? And then for 33, did you get, oh, this one was hard. There were two things going on. We had a shift down 6. But then you also had a flip over the x-axis. You had two things. You had a negative and you had a shift. You had a negative and a shift. Once again, if you guys are completely unable to use your worksheets to do homework, you need to come in and ask me, how do I do math? Because basically, if you don't know how to use those worksheets to guide you in trying or attempting your homework, you have a huge disconnect that we can fix, but you have to come in. And if it's just laziness, I can help you with that too. But if it's like an actual disconnect, come on in, bring your worksheets with you, bring the homework that you have tried, and we'll have a powwow. You guys, leave the homework out on your desk. I'm going to go ahead and pop open section 10. Ooh, that's not you guys. Your notes didn't open, and I'm not sure why, but I'll get them opening right now. You guys are going to go ahead and transition to a new section of notes. Those worksheets, you can put those totally away unless you have graphs on them. If you have graphs on them, turn them over and have the graphs ready to show me. I'm going to come around and grade your 5 through 20 as well as your homework from last night. But as I do that, we are starting section 10.3 today. Now 10.3, he's still kind of to do with radicals. But I actually have a warm-up for you guys to work on, and the warm-ups aren't graphing, thank goodness. The warm-ups aren't graphing. So keep your homework on your desk, and as I come around and grade, you guys are going to do the warm-ups 1, 2, 3, and 4. It's on the upper right-hand corner, and all it says is solve. So it's review from last chapter. Review from chapter 9. Can you try to solve the two problems that are coming on the warm-up of your paper? 1, 2, 3, and 4. Jerry, make sure Everest gets this one. 1, 2, 3. Shoot, shoot. So then you guys can keep your homework in your notebooks. Remember also that I didn't get to grade last time when we were finishing up chapter 9 because it was in your notebook instead of. Oh no, chapter 10. I wasn't able to grade because it was in your notebook, so I'm just going to peek at the last 3 homeworks in your notebook for you guys. But here we go. Section 10.3. You guys are trying the warm-up, and the warm-up just says solve with square roots. The warm-up says solve with square roots. So warm-up, solve with square roots. You don't even have to graph it. Oh, thank goodness. Do you guys see any graphs on this? No. Woo! Okay, good. We can take a break from all those tables. Although some of you are doing well. We can take a little bit of a break. All right, I'm coming around looking at homework swoops on their paper that came from absolutely nowhere. How did we do swoops every day in class? How did we do graphs every day in class? With a table. If you're just doing random swoops, you're not doing the process, and you're not going to be able to do it without a calculator, without someone cheating and giving you the answers, without some sort of pop-up math that just gives you the answer right away. So some of you guys are disappointed by me giving zeros or by me giving half credits today. Come on, you should have fully expected it. And for those of you guys, about half the class is like, I'm coming in today. I'm like, great, but what happened to yesterday? What happened to Friday? What happened to Thursday? Why do you have to come in the day that it's due? Why not come in early? That way you have it done the day that it's due. How would your English teachers feel if you said, oh, I'm coming in today to ask you about my topic and whether it's good enough, and they're like, the essay was due today? Would that make sense? No, the essay is due today. You were supposed to do the work before. Come on, crazy. Oh, All right, here we go. Warm up. Did you do it? Good. If you attempted it, I give you a thumbs up, and I appreciate at least you're trying to work when you're in class. The question is what you do when you're out of class. But for those of you that your warm up is completely blank, shame on you. Okay. Solving with square roots. You're supposed to at least try. It doesn't have to be perfect, but you were at least supposed to try. As you guys are looking at this, let me go get Danny a worksheet because for some reason, his row lost one, or I could have counted wrong. Does anybody else not get one from their group or from their rows when they pass them back? Andrew and Everest, you have your warm up up? Because we're doing the warm up right now.
Right here.
Okay, so hopefully you guys subtracted 20 from both sides. Maybe you forgot a little bit about how to solve, but maybe you remembered and you divided by 5. I hope, and you got x squared is equal to -4. But was that good or was that bad? Why was it bad? What's the next step you wanted to do? But am I allowed to have a square root of a negative? No. Which is why for domain we take the radicand greater than or equal to 0 for domain. Good job knowing that's bad. That's why we do this. That was 5 through 14 on the homework from Friday. So the nice thing is that one was super nice and easy because all you have to answer is not possible. Okay, but how about the next guy? A little bit harder, but did you guys divide first? It's all about order. It's okay if you made a mistake. That means you tried. But did you divide first? Divide by 25, divide by 25. We end up with x minus 2 quantity squared. I have to now do what to both sides? Because now the squared is ready for me to undo. Now the squared is ready. Thanks for looking for it. Square root. Now, when you square root a square, this is review, so if you don't remember, ask me a question in a second. How do we square root a fraction? Yeah. And what's the square root of 9? 3. You guys having these memorized yet? Square root of 25? Got them. Now, why am I putting absolute value? Slow it down. Good. And then Kayla, you were starting to explain it to us. Why are we or how are we slowing it down? What do we have to do? 2 different equations. One with the and one with the negative. Got it. See, you know things. Andrew, where did I lose you?
So what if you do a minus 25? Could you do that?
No, because sadly it's 25 times, and remember in algebra we have to do the opposite of the operation occurring. Does that make sense? It's a good idea that you knew to get rid of the 25. You just did the wrong step to get rid of it. Yeah. Now, guys, you might not like this. If I were you, I would change the 2/1 to be fifths. Because then 10/5, I can add 10/5 to 3/5 so much easier. And I would end up with a little bit of math, getting 13/5. And I can add 10/5 to -3/5 pretty easily. If you get common denominators, life gets a lot easier. 10/5 minus 3/5 is 7/5. You guys might have had to do a couple steps in between to get there, including getting a common denominator, which is what I did right over here, to make my life a little bit easier whenever I dealt with the 2. But, okay, hold on. If that was the warm-up, that was something we already knew how to do, well, what's going to be happening in all the problems down below? Has anybody started looking at what's going on in, number 1? No, actually, this isn't even, oh, hey, this is technically right up here on the left. You guys can see it, right? How do we undo a squared? When I went and got the yellow marker, what was I doing every time? I saw a squared, I got the yellow marker, and what did I do? Plugged in what? No, just now. When I saw a squared, I went and got my yellow marker, and what did I do? I put a radical, because what happens when I have a squared and a radical? They cancel out. So pause. What do you think we're going to do if we get a square root or a radical by itself? Exactly. Because if the opposite of squaring is square rooting, What's the opposite, or I should say the inverse, the undoing of a square root? Squaring. We're just going the other way. We're just going the other way. You're going to write it on your paper? You're going to tell your brain how to do these? Come on, help your brain out. It doesn't have to remember everything that you hear from your teachers during the day. You just have to have it written down somewhere so when you go to do homework, you can remind yourself. If I get a radical by itself, all I need to do is put in a squared, and then I still get to cancel it out. I still get to cancel it out. So, when I cancel this out, oops, let me make it full screen. I can cancel out my radical. I can cancel out my squared. And I get x is equal to 10 times 10 is 100. 10 times 10 is 100. Now, this is a little weird. Because some of you are like, why didn't you slow it down? Why didn't you do 100 and a negative 100? Well, it's a little weird, but guys, way back here, the square root was already there, and it was already a positive on the outside. So we actually knew that I was only looking for a negative times a negative, a positive times a positive. Whenever I square, I get a final answer of a positive, and that's my one answer. I'm going to show up here on the screen the next homework. It's not due until Thursday. But some of you, that's all you needed to see. It's square root alone and square. But we have some more practice, obviously, to do tomorrow. People with questions, if you want to come see me on your way out the door, I can totally try to answer them for you. I just needed to get to the end of the notes to show everyone that. My ones that said they were going to come see me, I really hope you do.
Will you be here after like 2:30?